Overthinking it already. Because that wasn't part of the notes. Alright, so we're going to wrap things up today. Last section in the chapter. So we are going to do some things where we are solving inequalities in two variables. Before we were solving equalities in two variables. So before we had 3x, it's roasting hot in here, 3x plus 2y equals 7, 4x minus 5y equals 3, right? And then we solved that for x and for y. Remember? All kinds of different ways. You could graph it, you could use a matrix, you could substitute, you could eliminate. So today we're going to do the same kind of thing, except now we're going to change this to maybe a less than or equal to, and make that a greater than. Okay? Nope. Go ahead, Bobby. It's all you. No, you can't put this in your calculator because unlike the solution when they're equalities, how many solutions are there when they're equal to each other?
1, 2.
Usually 1 because they'll cross one place.
Yeah.
Sometimes none, sometimes an infinite if they're the same number of lines. But when we're dealing with inequalities, since we're going to be doing that shading thing, there's an infinite number of solutions, and so you can't show that on a calculator, you can only show that on a graph. All right? So let's start with an easy one to refresh your memory how this all works. Let's graph y is greater than or equal to 2x plus 3. So tell me what you know about this graph. Y-intercept is 3, okay? Because it's 2x plus 3, the y-intercept is 3. And so that means I'm going to start by putting a little dot at 3 on the y-axis. And then the slope is 2. So from that point, I'm going to go up to over 1, up to over 1. Okay? Now when I connect these points, will it be a solid line or a dotted line? Solid. Why? It says greater than or equal to. Way to come in late and just hit the ground running. So yes, this would be a solid line that goes through those points.
I remember this now.
Yeah, and then since it says greater than, what do? I shade above that line. Okay? Good. So what this means is any point that I pick in the shaded area will make that inequality true. Any point that I pick in the non-shaded area will be false. So for example, if I choose that point right there, x is 1, 2, 3, negative 3, and y would be 1, 2, 3, 4. If I put negative 3 in for x, 2 times negative 3 plus 3 is negative 6 plus 3 is negative 3, right? That is in fact less than or equal to the y value of 4.
Yeah.
So that point is true over there.
So
So you're just testing it?
Yeah,
Okay.
exactly. That's actually called a test point. Nice job, Bobby. What?
Are the points on the line equal for that?
Okay, let's do that in just a second. If I choose any point that's not in the shaded area, 1, 2, 3, 4, 5, comma 2. For example, if I plug 5 in there for x, 2 times 5 plus 3 is 13, and that is not less than or equal to 2. Okay? So these points over here.
I thought the shaded area was what you couldn't.
Okay, the shaded area is the points that work. The non-shaded area are the points that don't work. What about the points right on the line, Taylor says? What if I choose negative 1, 1? So if I put negative 1 into here, 2 times negative 1 plus 3 is 1. Is that less than or equal to 1? Yes. And that's why this line is shaded, because since it says that that it's okay for them to be equal to each other, these points will work. Okay, but if it was only an inequality, that would be a dotted line, because then it would not be a part of our solution. Okay? All right, so that's review. It was good to hear that you guys were remembering these. Let's do something a little crazier. All right, how about x is greater than or equal to 2?
Y-intercept 2.
No, sir.
Why not?
Because. No, sir. Yes.
It starts at 2 and goes
Right.
to 1.
No, it doesn't go up one or over one or whatever. This one looks like this.
Doesn't cross.
Called it the smartest girl in class. And greater than means to the right. Okay? That doesn't have a y-intercept because there's no y in the equation. So it has no y-intercept. So the only way that you can have an x-intercept and not a y-intercept is if you have a line that goes straight up and down. How about y is less than -3? Okay, go to -3 and do a straight line. Oh, it would be dotted, wouldn't it? You got me.
And then it's greater than.
And then it's less than.
What? That's what I meant to say. So the part where the process. What happened?
Right, and then we'll get to this in a minute. So this place where it's double shaded would be the solution to that system.
Oh, that's right. Okay.
Right, that's where the points are both, the x coordinates are greater than or equal to 2, and the y coordinates are less than 3. Okay? Okay, why stop with linear equations when you're as smart as you guys are?
I totally remember you.
That's a good thing.
You got Florida Gulf Coast?
I do, yeah. Actually, they're one of my 18s, yeah, in a draft. I have Florida Gulf Coast and I have the South.
But it's still going on today?
So I got 4 teams still. Kansas and Florida.
I have Oregon.
Okay, what does the graph of x squared minus 3 look like? First of all, where does it cross the y-axis? -3. Where does it cross the x-axis?
Like,
1.5.
Close.
0.
No. How do you figure it out?
Well, because it's like the things 1.
Well, that's what we're trying to do. So yeah, good idea. The way you figure out where it crosses the x-axis is you put 0 in for y and then solve it. So if you put 0, right, plus or minus the square root of 3, which Gabe was close, that's like, what is it, 1 point, anybody know, square root of 3, off the top of their head? Like what?
1.7.
1.7? Okay, so it'll look something like this. What? Plus or minus, because we're going to take a square root, plus or minus. Did I miss? Oh, no, that was bad, huh? Sorry. Thanks, Justine. -1 point, there we go, okay. Thanks. Greater than or equal to means I shade where? Above. So in that case, that would be, or in this case, that would be inside the thing. Okay? All right, uno más.
are we doing the absolute value?
Oh, no. We're going to do one system. All right, so let's graph the system of equations. Y is greater than x squared. Yeah, I'll pass them out to you guys when I give you the assignment. So what does y equals x squared look like? Obviously, a parabola. It's your regular old straight up parabola. Y is greater than x squared, though, means that when I graph this parabola, I'm going to make it a dotted line. Okay? So that's going to look something like this. Negative 2 squared is 4. So my parabola is going to look like that. Okay, 2x plus 3y is less than 4 is in a little different format than the other one that we graphed. Does anybody remember the double intercept way of graphing those things? I'll keep that as a no. So you could take that and solve it for y. Okay, right. Or you can go like this. If I cover up the y, 2x equals 4 means it crosses the x-axis at 2, because 4 divided by 2 is 2. And then if I cover up the x's, 3y equals 4 means it crosses the y-axis at 1 1/3, 4/3. So I'll put a dot right here. And then connect those dots, and that'll be my line. So if it's given to you in that format, you can do that little cheating way.
Can you do the cheating way again?
Can I do it again? Yeah.
Like, you can do it on the same problem, so I'm writing on my graph.
Oh, I will.
Okay.
So if you cover up the y's, if you plug in 0 for y is what we're doing, okay, then that means 2x equals 4. So that means x has to equal 2. So that means I have a dot at 2 on the x-axis. And then if you cover up the x's, where again we're putting in 0 for x, 3y equals 4. So that means y equals 4/3.
4/3.
So that's a dot right there. Connect the dots and then we good. Okay? All right, so this parabola was y is greater than x squared, so that would be everything above the parabola, inside the parabola. And then this is, since it says y is less than 4, I'd have to shade everything below the dotted line. And so my solution area would be where both of those things are shaded at the same time. So that would be just that little tiny little wedge right there. Okay? So that place there is where all the points live that make this inequality true and at the same time make that inequality true. Okay? Kind of like a little Venn diagram. Sort of.
4/3, that's just up 4/3.
Yeah, so y-intercepts, not the slope. Okay? All right, so you guys don't have to copy this down on your piece of paper. I'll pass out some graph papers for you to do this on.
I got it. I got it. Everyone's just like graphing like these are all in the same thing. I know. I'll break it in both there. There, for sure.
And this was the last one.
Start.